So hey everyone, welcome back, and I hope you guys are doing well. So this question is really interesting. That this is not a standard problem. This is not something which you can like. This is not a algorithmic problem. It is something you can say a puzzle kind of problem, right? It is pretty interesting. You will actually got to learn a lot because here you are actually using your problem solving skills. Like what I mean that is that you are actually thinking about how to actually come up with a solution of such kind of problem, because that will actually help you in your OAs in your upcoming interviews, right? So this is pretty good problem. If you are not able to understand it or if you are not able to solve it, don't worry, I'm here to help you. So without wasting any time, let's get started. Let's see the problem statement. And one important thing, make sure whenever you are solving such problems or whenever you are reading, make sure to read it slowly so that you are actually going to understand the each important part, because sometimes what happen is you miss small little details, and that will cause you to actually not able to solve the problem, right? So let's see the problem statement. And if you are new to the channel, don't miss to subscribe to the channel for upcoming updates and for upcoming LeetCode content solution, right? So with this, let's read the problem. So you are given an integer array nums. Two players, Alice and Bob, plays game in turns with Alice play first. Make sure to write this as well. In each turn, the current player choose any subarray from nums first, okay, such that L minus R plus 1 should be less than M, where M is the current length of the array. Okay, this line is really important, which means I will discuss it in the later what exactly the line is trying to say. The selected subarray is removed and the remaining elements are concatenated to form a new array. The game continues until one element remains. Alice aims to maximize the final elements while Bob aims to minimize it. Assuming both play optimally, return the value of the final remaining element, right? So this is a pretty important piece of this particular problem, and this part is really important. So let's see the example. So this is example, and what we have to do, we have a two player Alice which wants to maximize uh, maximize the array element, and we have a Bob which wants to minimize minimize the um, minimize the array element, right? So what we have to do, like what, and make sure make sure like to actually understand who is first going to perform the operation, right? Alice is the first, and the Bob is going to be performed the second time, right? So this is the thing which, and what we have to do, we are allowed to remove any subarray, and make sure we are not allowed to remove the whole array, right? If you see the test case, or if you see the condition over here, they specifically mention that chosen subarray should less than the length of the array, which means we are not allowed to remove the whole subarray, right? So if you see from the example, so one valid optimal strategy is Alice remove once, then array become 5 and 2, and then why Alice remove one, because Alice wants to maximize, so he will pretend to keep the maximum element, but Bob wants to minimize, so Bob wants to keep the minimum element in the array and try to remove the maximum one, right? So if you see, Alice removed the first element, then our array become 5 and 2, then Bob came and removed the 5, the array become 2, thus the answer is 2, right? So you see what exactly is happening is, as we know, Bob tried to minimize the elements of the array, and Alice tried to maximize the array. So what Alice is doing, Alice is removing removing the minimum one uh, minimum elements, right? And Bob removing the maximum element, right? So this is the, actually, like, this is the operation which the both people are performing, and we just have to solve it. So like, how actually think about this particular problem, right? So first what I thought is, when I was solving this particular problem, right, which means Bob wants to like Alice wants to maximize and Bob wants to minimize. So why not just sort an array, and just for the in the every number, like in the every step, Alice remove the first element, then Bob remove the second element, and we continue this number of this operation until we only have one element, right? I thought it would work. Let's see what it is. For our given test case, our test case is 1 5 2. if we sort an array, our array become 2 5, right? And what I'm telling is at least remove the first element, which means let's Alice remove the first element, Bob remove the second element. The number of element which remains is 2, which is actually our answer, right? 2 is our answer. If you see, 2 is our answer, right? So it is correct. But let's see another test case. I uh, I later on I realized that doing this particular operation is not going to give me the answer which actually I'm looking for. For example, uh, if the array is 4 5, right, and if I sort it, so it become 4 5 and 11, right? And if I remove, let's say if Alice remove this one, Bob remove this one, so my array and my like my answer is going to be 5, but the answer is 11. And how 11 is coming, let's understand it. What I'm telling you, that the first thing which came into my mind is that we can do it like this greedily. We can just remove the element from front to back after sorting, so that will actually help me to actually come up with the answer. But it is not the case. The problem is not asking us to do this stuff, right? So how to actually think about like why the answer of this particular test case is 11, right? So if this is the test case, so just understand it, right? What we actually want is, we want like first, whoever is performing a first operation, we want them to perform the operation optimally, right? So that we don't get a chance for the other person to actually perform optimally. Either we are allowing them, but we are actually playing it in a more efficient way. What it means is like Alice is going first, so we want to remove as much element as we can, such that the rest of the element should be the maximum element, right? So, but here is the thing that as I thought previously, that if you see, let's see, if you see, this is the test case. This one is the test case. So if let's see this one, right? This make more sense. If this is the test case, if we are allowed to remove m minus 1 elements, right? We are not allowed to remove the whole elements of the array, right? So Alice is going first, so he is allowed to remove the m minus 1 elements from the array. So what he can do, he can remove the m minus 1 elements. So our main goal is to actually remove as much elements as we can. So he also, like, she also wants to remove as much elements she wants, right? So what we can do, if you see, the previous approach of ours is not working, right? So but we are allowed to remove m minus 1 element, which means that for example, if we remove 1 from the array, then Bob have a chance to actually remove 5, right? And then we came to 2, with 2 is our answer, which means if you see this clearly, right, if we remove the first element, or even if it's a subarray like this, if we remove the first two elements, then Bob have a possibility to remove the fifth like the element which is occurring at the second index, which is 5. Why? Because it is occurring in the middle, right? Which means if we are removing a subarray, then whatever the element is coming in the middle, Bob is also going to remove that particular element, right? So it is able to, like, it is giving us a clear idea that whatever the element which is coming in the middle is going to be killed by the Bob, right? So what the important thing this particular thing is telling us, which means that if we remove these two elements, then Bob have a possibility to remove 5 or 2. But why he remove 5? Because 2 is minimum but 5 is maximum, so he wants to minimize, right? So he will remove, like she will remove, sorry, she will remove the 5 from the array, right? Then the array become 2, which means we are removing the first few elements, then it has the probability, like she has a probability to actually remove the middle elements, which means she's not removing, or she's not able to perform operation on the element which are on the corner, right? Which means the corner element are really helpful for us to actually come up with the solution, right? What I'm trying to say is, I'm just using this thing and the example which I tell you, that if we remove few elements from the array, let's say my array is 4 5 3 4 5 5 6 or 2, right? So what I'm saying is that if I remove element till this position, 4 5 6, then Bob will definitely remove fifth element, like the element which value is a 5. Why? Because she wants to minimize, right? So which gives an idea that the corner element are really going to help. Like corner elements are important for us. Let's say if we remove 5, then Bob definitely removes 6, right? If we remove and we want to maximize, then we remove 2, then it will remove 5. So we see the middle elements are always going to kill by the Bob, right? So this doesn't make sense to actually use those elements. So what's the better thing is, we should keep take care of the corner element, because that is going to help us, right? And what one thing which I observed, that we are allowed to remove m-1 elements, right? Which means except one element, if I give Alice a opportunity to remove all the elements except one element, so that is also going to be the best optimal way of him to her to actually perform the operation, right? So what I do is, like this, let's say this is the example. So if I remove m-1 element, if I remove all of them elements, then the array become 4, which is the maximum which we can get. And Bob do not have any number of operation to perform, because the array size is 1, right? So this is what we are going to do. Make sure to understand why m-1 is working, because we are removing m-1th element, and the rest element is our answer, right? Same case, if it is like this, then we are removing these elements. We are removing m-1 element from here to here, right? We are not considering 2, because 2 is going to be our answer which we are going to use in our result. So this is the question which we are asking. This is the like actual approach to actually come up with a solution. The solution is, if you see the solution, you will see that the solution is pretty easy, but the thing is how to actually think about this particular problem. If you are not able to understand it, watch video again, you would definitely be able to understand. Make sure what I'm doing is, I want Alice to remove as much element as she can, right? So that is why I'm removing m-1 element if it is possible. So the corner element are going to be the part of my answer. You see, if I remove this part, then our answer is this one. If I remove this part, my answer is this one. So the only thing which is, we just have to pick the maximum of both of the values, because we want Alice to maximize his answer, right? So this is the actual explanation of this particular problem. If you're not able to understand it, don't worry, try to watch it again. Use use copy and pen, try to dry run the problem, try to dry run some test cases by your own. You will definitely going to understand what the main intuition behind this particular problem, right? So this is the whole idea about this. If you see the code, it is pretty easy, like it is nothing more complicated. We are just passing the maximum of nums and 0 and nums of the corner element, right? And we are just returning it. If you see, it is working fine. And talking about the time complexity, which is O of 1 and space is O of 1, so this is working fine. If we just submit it, I already submitted that particular question, so yeah, it is working fine. So I understand that for the first time it has become really little difficult to you to actually understand, because it is kind of a puzzle problem, not actually a algorithm problem. So you will definitely going to learn a lot about from this particular problem, that these problems are actually helpful you to actually solve such problems in upcoming OAs and upcoming interviews. So this is it for the video. I hope you understand the solution. If you're not, watch it again, you will definitely going to understand. I believe you can understand this, and I hope you like this video. And if you're able to understand, do let me know in the comment section. If you have any suggestion, do let me know in the comment section. Subscribe to the channel, and until then, happy coding. Bye bye, take care.